Okay, AP Stats fans, we're going to finish off our notes that we started the other day. This was worksheet 6-1. Before we begin, though, let me give you your joke of the day. How do you know if a vampire is sick? Anybody? You can tell if it's coughing. Hey, this is my study hall, so there's actually some students in here, so if you hear them laughing at me or something, then that's what it is. So, we finished last class, we were talking about expected value, and we talked about, here's the formula. We were looking at the number of siblings, or the number of children in each person's family in class, and what we did was we took those numbers, 1, 2, 3, 4, 5, and then 6 plus, and we multiplied by the probability of each value coming up. And what we ended up with was a fraction, which we turned into a decimal, 2.5882. And the expected value, that is the mean. That's another word for the mean of our data. It's the average of all the possible values of x. Okay, so we're just kind of summarizing. This is what we were writing down last class. Now, the official way, if this was an FRQ, to guarantee that we're getting full points, we're going to say, if we randomly select an AP Stats student from my class many times, okay, not just one time, but if we do this over and over, the mean or the average number of children in that student's family is 2.5882. Okay, and we talked about the fact, if we just choose one person, we can't get a decimal for that. Because our numbers that we chose, these are discrete values in this case. But if we do this many, many times, we can certainly get decimals, and we almost always will. Okay, so that was where we left off at the end of that class. So there's a couple more things we're going to look at calculating. I'm going to show you how to do it by hand, but then I'm going to also show you the calculator, which is the way that you will want to do it in terms of a test. Okay, so some things that we also talked about back in chapter 1, besides the mean, the average, we talked about variance and standard deviation. Now, the variance is actually the standard deviation squared. Now, in this case, because we have this variable x, and we defined x on the front to be the number of children in each person's family in the class, the standard deviation of x squared. And that is the average squared deviations, which we would write as each x value minus the mean. So how far away is each number that we have from the mean? And we square it. It's the average squared deviations of our values x from the mean. And we could write that formula. The variation of x is the standard deviation of x squared, and it is the sum of those values squared. But then what we're going to do here, when we're talking about expected value and standard deviation, we're going to multiply that by the probability of each thing happening. Okay, so what I wrote down here, this was our definition from chapter 1. But now that we're dealing with random variables, we are taking the sum of these squares, and then we're multiplying by the probability that each thing happens. Okay, so if we were going to work this out by hand, and normally we would not, but what we would do is we would start with our first x value, which was 1, if we had one child in the family, and we would subtract that from what the mean was, and I'm going to round that to 2.59 squared, but because the probability of each value was different, we're going to multiply it by that probability, which was 3 over 17. And then we're going to add that. The next x value was 2 children in the family. How far away is that from the mean? We subtract it from 259, or 2 minus 2.59 squared, multiplied by that probability, which was 5 over 17. We do this for 3. So what we're doing is we're asking ourselves how far from the mean are the values and how often are they coming up, basically. And then we had 4. And the probability of that was 1 over 17. We did not have 5. Now we could still write down 5 minus 2.59 squared, but the probability was 0 over 17, so that will just be 0. And then the last one was 6 children subtracted from the mean, square it, multiply it by the probability. Now, you would want to use a calculator if you're going to do this. And again, I'm going to show you the quick way in a moment. Even with the calculator, you need to be really careful as you type this in, because there are a lot of places where we can make mistakes. And we keep going here, almost done. And then the last one. And you can see why even with this calculator, this is kind of a long process. So there is a faster way. All right, enter. And what we get is 1.41, and I'll round that to 9. 1.419. Now that is the variance, and that's the same thing as the standard deviation squared. To take the standard deviation, we just take the square root of both sides. And so if we take that, okay, and I can type my previous answer in there, and we get 1.191. 1.191. Okay, so now let's write down in words the standard deviation. Now the definition from chapter 1 is how much our values of x, whatever that variable is, typically vary from the mean. Okay, talking about how spread out our data is. If we randomly select a point, what would be the average distance from the mean? Okay, now we don't use the word average there, but how much the values of x typically vary or differ from the mean for that. Okay, so in this case, the standard deviation was 1.191. So the way that we want to write this, there's kind of a form for this when we're writing this in terms of an FRQ. So we start with whatever the data is that we're measuring, typically varies from the mean. And in this case, we'll say the mean was 2.5882 by something. Okay, so the middle part is going to stay the same no matter what, other than this number. Well, what was it that we were measuring? That was the number of kids in a family. Typically varies from the mean, which was 2.5882, by, and the value we got was 1.191. And I do want to write down what the unit of measurement was. In this case, that was children. Okay, so there's standard deviation. The formula for standard deviation is we would take this and then we would take the square root of it. Now this would be something that you do not have to memorize this. The standard deviation formula is given to you on the AP exam, but even though we have it, we would not want to use this. We certainly want to do this a simpler way. So let me show you. If we take the calculator here and we'll go to a new document. Now we're going to go to lists and we're going to type in some data here. We're going to type in the X value first, which was the number of kids, 1, 2, 3, 4, 5, and 6. Now at the top of this, I'm going to label this, since we're talking children, I'm going to call that C. Now next to that, we're going to put in the probabilities. So we're going to type the fractions in. It was 3 over 17, 5 over 17, 7 over 17, and then it was 1 out of 17. Now for number 5, nobody had 5 children in their family. We need to put a number in there though, so we're going to put 0. And then the last one is 1 divided by 17. And I'm going to name that list, I'll say P for the probability of that coming up, or that would be the relative frequency. That was another thing we talked about in chapter 1. Okay, now we're going to come next to this. We're going to go into column C, and we're going to go to menu and statistics and stat calculations, which is that first one. And we're doing one variable statistics. Now we were doing linear regression. That was the a plus bx there, or the mx plus b. This is only one variable. And you might be saying, but wait a minute, we just put in 2 lists. We did, but that second list was not really the data, it was the probability of that data occurring. So the number of lists is still 1 when I type this. Now let's see, the X list is, I want to make sure that that is the children. All right, so that was C. The frequency list. Now in chapter 1, we just skipped right over that and we went down to OK. But the frequency, that was the probabilities that we typed into list 2, which we called P for probability. Now we're going to come down. The first result column, they're just going to put the answers into D. That is fine. And we'll say OK. All right, and now we have the X with the bar is the mean on the calculator. Well, there was the mean, 2.58824. That looks good. We did that right. And then we come down here to the standard deviation, which was 1.19109. Okay, and that's exactly what we got here when we took the square root of the variance for that. All right, so you can type all those in on the calculator. That is how we are going to do it in this class. I'm just showing you where the values are coming from. This was the expected value. How do we find that average? And again, the calculator will do it for you. And then with the variance, okay? Too much work to try to write it out, so we can use the calculator to come up with those values. And then the last thing, this example was with discrete random variables. And we talked during class also about the idea of a continuous random variable. And that might be something like if we're measuring time, if we're measuring heights, weights, things like that. Because the continuous random variable, it takes all the values in an interval of numbers. And one of the examples that we talked about is if you roll a die, or if you roll dice, well, we can get 1, 2, 3, 4, 5, 6. But you can't get a 1.1. So that would be discrete. But if we had a different thing that we were measuring, and any value between 1 and 6 was possible, now we're talking continuous for that. And when we graph that, instead of using a histogram or something like that, we can use a density curve. And the idea is that everything, all the data points, have to be at or above the x-axis. And then we know that the area under the curve has to always be equal to 1. So this is a density curve. The one we are most familiar with that is going to come back in chapter 6 is the normal distribution, where we have the mean and the standard deviation. And we have our positions and our percentages under the curve. And that is the end of the notes.